Hello everyone, today I will introduce hw1 KNN mating. This assignment focuses on understanding how image mating can be formulated as a graph optimization problem. So instead of treating pixel independently, we treat pixel as a node in the graph. So you can see in this image, there are many nodes and each represents different pixels. And the white one is the opacity has the opacity we want to calculate, and it can be calculated by its neighbor. And after we get the opacity, we know all opacity of nodes can easily separate the foreground and the background. So for example, in this slide, we can see the original image and a trimate. And after mating, the foreground can be composed onto a different background. But how? The trimate is the key. And the trimate will be represented like this picture. It divides the image into three regions: white, black, and gray. So the white stands for foreground, and black is background, and white and gray is unknown region. So we need to calculate the unknown region and to get the opacity of the gray region. And so after we know the opacity of the gray region, we can separate foreground and background just like this, just like the right side. And if we see it in the graph view, each pixel is treated as node in the graph. For every pixel, we find its k near its neighbor using feature similarity. Then we create edge between similar pixels to form the graph. And this allows alpha value, which is opacity, to propagate across similar region, which is known as stable propagation. The homework has three main steps. First, find k near these neighbors and build the affinity matrix. Second, solve a linear system to estimate opacity. Third, compose and extract foreground onto a new background. So to begin with, we need feature factor as node that represent the pixels. You can use RGBXY to consider the color and spatial similarity, or design the other representation. Next, we construct the affinity matrix. This matrix encodes the similarity between pixels. However, computing all pairwise similarity will be expensive. So we first perform KNN search and only compute affinity with this kernel function for the nearest neighbors. And this makes the matrix fast, which is important for efficient computation. After building the graph, we solve the linear system to estimate the opacity. And it is represented by this symbol alpha. And by optimizing the objective function here, we can obtain the optimal alpha value. And you should be aware that the objective balance between two goals, smoothness and user constraints. So maybe you can tweak a little bit, tweak along the lambda value to get a balance between the two. And finally, after all that, we can use the alpha value to compose the foreground onto a new background. Using this formula, the F is represent foreground, B is background, and alpha is the value we just compute. And finally, you will get a finally composed image, C. And the workflow is like this: is a foreground and a new background, then get a new image. As for requirements, the homework is divided into basic and advanced parts. So, and you should include all of the following the report. We provide a template for you. Please follow the formats and complete the requirement mentioned template. And so you can see there will be 3 cases you need to apply. And the easiest one is bare. You have a clear background and clear foreground. So and clear edge, so you can easily separate. And a little bit harder one is woman because it have very hair, so you need to separate. The pixel is so small, so it's hard to separate. And most difficult one is the white coats because you need to differentiate the white differentiate it from the white wall. It's all the same color, so it's a little bit harder. And for the bench part, you need to tackle white coats, white wall problem, which is a cases, it's a third cases. And so if you just separate it, but with the weird tri-map results, you will get the basic point, but the defense part maybe you will not get the point in this session. And this session will be judged based on how you outperform others. And the next session is you need to speak up large linear system, because if you solve directly using the closed form formula, it's extremely time consuming. So maybe there are other methods you can try to speed it up. And the next one is compare with other mathing methods. In the lecture, in the class, there are many mathing methods mentioned, so you can try it and report and write the report, including into your report. And your score for this session, your score will be judged based on the effort you put into it. Submission. The deadline is March 31st at 11:59 p.m. and there will be a 10% deduction for each week of late submission. Every submission should consist of the following: your Python code, report, and please follow in the template. And you should put all the file into a lib, and your file name is student ID, your name plus hw1, and submit through E3. And for the reminder, please do not submit copied code from the internet. If you referred open source code, you must probably cite it. Otherwise, penalty may apply. So that is our homework 1, and thank you.